found the old one. And then obviously somebody asked me, so do I have to show the paragraph? Yes. So do I have to show the paragraph? Yes. And if you're not showing the paragraph, then you're not doing things the way you're supposed to. If you just make random tables and disregard the directions, then you're not doing what you're supposed to. You're not doing credit. So pay attention to the directions. It says sketch the paragraph. So the paragraph is the dash line. And then this says compress, okay? And you see the half. So this point right here, think about it, it's at 2. The height is 2. So what happens when I multiply? So what happens when you multiply 2 and a half? You get 1 right there. What happens when you multiply 1 times a half? You get half. 0 doesn't change. And the same thing happens here, right? Because there's the symmetry right there. And then this is your new, right? This is the new graph. This is the parent graph. So you can visualize right there what's happening. The graph was like this, but then after the changes, it basically looks like it got wider. Yes, it looks like it got wider, but the correct math terminology is compression. And to be specific, it's a vertical compression because not only can a function do this, but it could also do it sideways. Okay, it could do it sideways because there are two types. Okay, and even though we're not going to actually do the horizontal stretches in Math 3, we do them in calculus. So please make sure that you are aware of it. Okay, so number 3 is showing you a reflection. So again, dash line is the parent. So this is the parent graph right here. Okay, and again, I would get it from like right here. Like, oh, look at that. There's my parent graph. Really quick. Making a quick reference. And well, when there's a reflection, so right here it says it's reflecting across the x-axis, then basically all the y values change sign. So this was up here at 2, and then it drops to negative. This one was at 1, but then it drops to negative 1. And then 0 never changes, and then 1 drops to negative 1. So everything above the x goes below. So this is a reflection across the x-axis. There's, so all the dots are just a mirror image of each other, like that butterfly symmetry kind of thing going on. So when we're talking about a symmetry across the x-axis, it is always the fact that there's a negative number in the front of the function. So that's the part that you have to remember, that a is in front of the function. So you have your function, right, whatever it is, and a is in front. Okay, so there's going to be other places where I find negative signs, but if it's not in the front of the function, then it's not this kind of reflection. It's different. Okay? All right. So, questions so far before we start sketching? Any comments or questions? Okay, deep breath, deep inhale, and so here is the first one. Okay. I picked the quadratic to start with, and then I just kind of ignored the quadratic for a while because we did this last year. So I know that you've done this before, and this one's just going to take us into the new functions, okay? So you see the dots that I already plotted? I went to this table right here, okay? And I just copied them. So see negative 2, 4, negative 1, 1. I copied these dots. Okay, so basically what I want you to do is I want you to identify, this is the paragraph, okay? I want you to go to your sheet, find it, and plot the points, which I pre-plotted just to save time, okay? And I'm gonna write down the table here so that it's together with my notes, okay? But then I'm not gonna keep writing the tables over and over, because then it takes too long. So if you're referring back to your sheet, okay, and I kind of just memorize these. them over and over so they just stick in my brain. Alright, so what is happening? This is the A number. And what does the A number do? It's going to be a vertical stretch by 3. So what is this 3 clearly doing to your function? It's taking, see all these y values on your table, and multiplying them by 3. Every single one. Multiply by 3. That's what the task of this number is. So you're not going to change your x values. Negative 2 is going to stay. Negative 1 is going to stay. But 4 is going to multiply by 3, and then this dot jumps up to positive 12. And 1 gets multiplied by 3, so it jumps to 3, and 0 doesn't change. And then that's what you get. This is your new function right here, the one in green. Ta-da, that's it. So we show the parent graph, right? Right here, you have to show. So somebody was asking, do I have to draw the parent graph? Yes, forever. Okay? And then here's your new graph, the one that's in green. So that 3 is the A, and that's describing a vertical stretch. And then there's my graph showing that stretch happening. And the only other thing here is that I'm asked sometimes to do is to determine the domain and the range of the new graph, okay? But it turns out that the domain is actually all real numbers. Once it says all real numbers on your function, it's all real numbers on all the new functions. And your range is the only one that could be a little bit different. So we have to look at it. I mean, is it still sitting at 0? Yes. Is it still going to infinity? Yes. So when you're looking at the range, remember that vertical look, okay? So for my range, it's going to not change. It's going to be the same exact way as the other graph was. Okay? So this is old. This is Math 2. I did this last year, in Mrs. Rodriguez's class, or Mrs. Folks, or Mr. Berglund, whoever your teacher was last year. We did these transformations. So now let's go with the new. So here is new. Why is it new? Because it's a new function. Okay? So let's do the same thing. Okay, baby steps. So first, find the parent graph. So let me change color for this. So this part right here, that's your parent. Okay? I'm going to write the table one more time. So if you were looking at my paper right here, okay, it was number 3 here. There it is. Okay, I'm just copying everything from there. So let me squeeze in a table here for you. Here are the dots. So I actually put the dots on like the first 2 graphs of your homework, and then I stopped putting the dots. And then somebody asked me, so what do you do if the dots are not there? I go, you put them with spell. So that means you have to go back and look at the parent graph and then sketch it on there, and then use that to value to create the new one. So this is the parent graph, okay? All right. So now let's analyze the negative 2. That's got to be the A. So the fact that it's a 2, just a 2, okay, represents that it's a vertical stretch by 2, okay? Second, there's a negative on it, so that it represents that it's going to reflect across x. Okay? So what you're doing with this A number, remember, is you're going to multiply it. So right here, you're going to multiply this negative 2, and you're going to do it to the negative 8, the negative 1, the 0, to the 1, and to the positive 8. And what's nice is that that number, because it's negative, it's going to automatically stretch and reflect at the same time. So we wrote this in like two different transformations, but the A is nice because it takes care of both of them together. So this dot that was at negative 8 jumped up to positive 16, and the dot that's at negative 1, it jumps up to positive 2, and 0 stays the same. And then this one changed to a negative 2 because it was positive 1, and then the positive 8 became a negative 16. So you multiplied it, and there you go. That is your graph right there, the 1 degree graph. And what we want to see from here is we want to understand, oh, what this number does then, it takes this graph and it reflects it and it stretches it. That's the skill that we're trying to analyze here and we're trying to learn. So it's not just about make a table of values and sketch it. That was the worksheet that we did for the second homework. That's what the idea is there. Just make the random table and see what you get. And some of you were a little bit stuck because you were like, some of these numbers are getting too high. And that was the whole thing about the exercise. Analyze what's happening and see that the tables sometimes could be tricky to do. So now we want to look at this and compare it to the paragraph. So what about the domain here? Wasn't it all real numbers already? And wasn't the range on this function all real numbers? Okay, so again, once this is defined on your tables, this is it. Even if it's a new function, it doesn't matter. Those all real number situations, they remain the same on anything. So if you go back and you look again at that paragraph right here, look right there. Okay, this was defined on Wednesday. So when you're doing your new graph right here, that's not changing. This is going to stay the way that it is. All real numbers. Okay? I'm going to just breathe really quick. Alright, let's continue here. Alright, so I'm going to skip one of these just because I want to make sure that we get to the activity. But we'll do, like, if we won't graph it, but at least we can do like the describing part of it. So let's go to C again, look at the paragraph. So my parent graph is right here. The parent, right? And then this is the one that had like the shortest table. Okay. I don't know if you remember that we said we had to start with 0 for that one. And then we did 1 and we did 4 because those were perfect squares. And if you see the 3 dots, I already green dots. Okay. So I think once we get to like the third example, it's like, okay, this makes sense. So figure out what the parent graph is, put it on the graph, and then come back and figure out what this number is doing. Okay, so that's my A number. My A. Okay. So what is that number telling you? There's a negative, so you should be saying that it reflects across the number, specifically the x-axis, and because the number is bigger than 1, it's a vertical stretch by 4. So everything is getting 4 times 1. Okay, so when you look at the graph here, you're getting 0 and 1 multiplies by negative 4, and 2 multiplies by negative 4 multiplies by 2 multiplies by negative 4 gives you negative 8. And then look at the graph. So you see the reflection, you see the stretching. So heights, think of the heights. So when we're talking about heights, we're talking about this height right here now became 4 times bigger down there. So this height right here is now 4 times bigger there. Okay, so that's what we're saying when we're talking about stretching. It's getting taller, longer, the height is bigger, the heights are multiplying by upside down because the negative makes it get upside down. Okay, or flip around. But we don't want to use that vocabulary. Alright, so let's just come back and finish the domain. So when we did the domain of this function, we said that it started at 0 and went to infinity, and that's still doing the same thing. Look at the graph. It starts at 0 and it's just somebody said, oh, so if you have arrows, it's infinity, but the range you was starting at 0 and going to infinity, but now because that it, it did the whole thing with the reflection, so now it's actually just stopping here, okay? So it keeps going down for the range. So the way that we're going to write this is we're going to say, oh, it stops at, so remember the second number is the stopping one, or the highest it reaches. So then negative infinity would be on my left side because it's going all the way down to infinity for its lowest number, and it stops at 0 because that's how high it gets, and that's it. It's done. Okay? All right. So, questions for letter C? Okay. Hope we're doing good. So, again, I'm not going to sketch this one, but let's just describe it. So this, again, is my parent right there. All right, so I can just write that down. And then here's the parent right there. Okay. And so let's just describe the transformation. So what is this number doing here? Okay, so this is the A number. And negative means reflect across X. And this is also a vertical stretch. So we've been doing stretches over and over and over. So somehow I always forget to include the compression. So on the last two examples here, I'm just going to change them to compressions because I completely forgot to put some fractions on here. And I think it's just kind of like subconsciously, I know that we don't like to work with the fractions, or you guys don't like to. So it's like I left them off on purpose. So give me here, and when you change this, okay, so let's make it 1/2 times 2dx, and then let's change this one too, make it 1/2. So we practice some of the compressions, okay? All right, so I'm gonna just finish up these, practice some equations, and then we're gonna introduce b, and it's really not gonna be that much more difficult. You just have to understand A is in the front, and then understand where B is at, and then see the comparison to help you when you're trying to identify those transformations. So looking over here, okay, and if you look a little bit above here, this is that exponential graph, and here's the table, negative 2/24, negative 1/2, etc. And this is the way that it looked like, okay? And then come back over here. So you're with me. Okay. It's really hard here with the graph sometimes. If you would have been here, I would have been printing these notes for sure for you. So if you can't print stuff, I know just write things at a time, especially because we're going to be graphing like this entire unit. So make sure next week that you have stuff printed ahead of time, or write them ahead of time. Okay? For sure, write them ahead of time to help you don't get behind and think, oh, you're sketching and you understand the explanation. So this is my paragraph. Okay? It's in blue, so I'm trying to be, coordinated here. And then what's this number doing? We call it the A. Okay, there's no negative signs there. Good. So all it's doing is it's showing me a vertical compression now. So compression means that it gets shorter. Okay, and then you just say bye. Zoom in here. I want you to just not even focus about the table and multiplying half, but just think about what's happening to the height. So let's start here with the taller one, okay? So this height at 4, so see, when I say 4, I'm looking at the height of it. So this here, it drops to 2. So nothing's happening with the x's, it's just my y vector. And this height that's at 2 drops to half. And the height that's at 1 becomes half. And I know that this little tiny space is really little already, but it also squeezes in there. And then same thing right here. And it's supposed to be like halfway, so it has to to be above the x-axis, and it has to look like each other, okay? And that's your new function right there. So I don't even have the table here. I didn't do any multiplication. Somebody was asking me, like, how do I enter this in my calculator? I said, stop with calculator. So you're looking at the graph and you're using the graph so that you can create that new graph. So this becomes my new graph, and then when we talk about the domain, well, guess what? It was all real numbers, so it's still all real numbers. And the range, well, the range here was a little bit tricky because we had to remember that it was above the zero, but this function is still respecting that. It's still above zero, and it's going to infinity. Okay? That's it. So start the next one. So it's going to be the same exact compression, 1/2. Okay? Again, you want to identify your parent graph. Parent. Right there. Okay? And then you want to identify your A. And describe your A. So vertical. And then you're going to ask me, do I have to write vertical? Yes. If you don't write vertical and compression, it's like you didn't write anything. If you don't say by a factor of 1/2, then it's like you're not understanding exactly what it is that you're doing. So don't be lazy on the homework. Write things, because then what happens is that when you make those bad habits in the homework, then you do that on the test. Okay? So again, so the heights are just, think of them as dividing by 2. So a 2, and then 0 doesn't change, and everything is half as tall. Half as tall. Right there. So a 2 drops to 1, a 1 to half, and the graph looks like it's got wider. Okay? So we call that a compression, and then when we describe the domain, nothing really changed. Nope. And how about in the range? Did anything change in the range? Nope. It's still at 0, and it still goes to infinity. Okay? So you're looking at the new graph to describe the domain and the range, but you're using your parent graph as a reference. Okay? All right, so I'm going to pause this a little bit. Take your pictures if you missed something. Okay, so we're going to take a little tiny break from graph, go to the next example, and then talk about speed, and then that's going to be like speed of the discussion. When we come to H and K, and sorry, Wednesday. Wednesday we'll do H and K, and then when we meet the next time after that, we put all the transformations together, so we have to know A, and mix them all up. Okay? All right. So let's take a break from graphing. This example is just you putting together the function. So I want to write an equation. Okay, an equation. Okay. So the first task